To do this, we're going to make some simplifying assumptions. The first assumption is a Markovian assumption, and that's that only the immediate past matters. So what this says is, if I know all of the states up through t minus 1, and I want a prediction of the state at time t, that just depends on the state at t minus 1. Now, these are x's, not the y's. These are if I actually knew the state. What this tells me is, if I wanted to predict the state on Wednesday, and I knew the state on Tuesday, Monday, Sunday, Saturday, it's all the same as knowing the state on Tuesday, okay? I only have to know one prior state. Now, some of you might ask, but wait a minute, if I know Monday and Tuesday, I might be able to estimate the velocity for Wednesday.
If I know Monday and Tuesday, I might be able to estimate the velocity on Wednesday.
So that's right, except not, because your state can also include the velocity, right? So if I knew the position and the velocity on Tuesday, I make a prediction about Wednesday. So this is the Markovian assumption. This probability of xt given xt minus 1, that's what we refer to as the dynamics model. That's how things are changing. Second simplifying assumption, we're going to assume that the measurements, the probability of the measurements, remember these are noisy measurements, given everything in the past and the current state, only depends on the current state. So this is where we say that the probability of a measurement given a particular state and everything else only depends upon the state. By the way, this is called the observation model, and I will tell you it is this particular assumption that is sometimes the most suspect. One way you can think about this, suppose you have some noise in your sensor that is related to some other processes going on, and it changes in a particular way that you might be able to estimate. This thing says, well, I don't look at my previous measurements in order to make that prediction. So for everything we're going to do, we're going to make use of this observation model where the likelihood of the measurement depends only on the current state. Just know that for more advanced things like conditional random fields and other approaches, we're actually be able to make the current measurement tied to previous measurements. But we're not going to do that here. I know some of you have taken various machine learning courses and you're familiar with graphical models. And if I were to draw up this set of simplifying assumptions as a graphical model, it would look like this. And what this says is that some state x depends only on the state at time t, depends only on the state at time t minus 1. And furthermore, it says that my measurement depends only on the state. And whenever I look at that, I always think to myself, okay, that's a joke. Why? Because those of you who know what this is a hidden Markov model, an HMM. See, now Megan, who is helping me with the slides, she didn't know that, so she didn't know how funny that was. So she's now, what is it, ROTL? No, or ROTFL, sorry, I left out the floor. It's really hard to say emoticon things. Not emoticon, what do you call those things? Whatever they are. Now she's getting up.